Hello friends, now we see the problem number 5, which is based on first principle of derivative of chapter differentiation. The problem number 5 is fx is equal to square root of sin x. Now let's see the solution. First of all, we start with f of x is equal to square root of sin x. Therefore, the next step is f of x plus h, that equal to square root of sine in bracket x plus h by first principle of derivative. F dash x is equal to limit h tends to 0 f of x plus h minus fx whole thing divided by h. So that equal to limit h tends to 0. Now f of x plus h, we substitute square root of sine of x plus h minus for fx we substitute square root of sine x and whole thing divided by h. Now here the radical part present in the numerator, it means we have to rationalize the numerator. So on rationalizing numerator, so the next step will be limit h tends to 0 square root of sine in bracket x plus h minus square root of sine x, that is in one bracket, next bracket square root of sine of x plus h plus square root of sine x whole thing divided by h into square root of sine of x plus h plus square root of sine x. So that equal to limit h tends to 0. Now numerator is of the type a minus b, a plus b. So that gives us a square minus b square. So in present case, square root of sine of x plus h represent a and square root of sine x represent b. So the next step will be limit h tends to 0 square root of sine of x plus h, that whole square, minus square root of sine x, that whole square, and totally divided by h into square root of sine in bracket x plus h plus square root of sine x. So that equal to limit h tends to 0. Now here square and root cancel. So we have sine of x plus h minus, again here square and root cancel. So we have sine of x only upon h into square root of sine in bracket x plus h plus square root of sine x. Now the numerator is of the type sin c minus sin d. So here we apply the formula that sin c minus sin d, that equal to 2 cos in bracket c plus d upon 2 into sin in bracket c minus d upon 2. So by using this formula, we have limit h tends to 0 to cos, in present case x plus h represents c and x represent d. So x plus h plus x upon 2 into sine in bracket x plus h minus x upon 2 whole thing divided by h into square root of sine in bracket x plus h plus square root of sine x, that equal to, now here 2 is a constant term, so we take outside the limit, so 2 into limit h tends to 0 in bracket cos of, now here x plus x, that gives a 2x plus h upon 2, and finally the square bracket complete. Now in the second limit we write limit h tends to 0, we cancel plus x minus x, so in bracket we left with sine of h by 2, and in the denominator also we have h, so that also I can write h by 2. To get adjustment, here what to do, we have to multiply by 1 by 2 and then totally divide by limit h tend to 0 square root of sine in bracket x plus h plus square root of sine x, and finally the bracket complete. So that equal to 2 into cos in bracket 2x plus, now for h we substitute limit 0 upon 2, then limit h tends to 0 sine of h by 2 upon h by 2, by rule we get 1, then again into 1 by 2 and whole thing divided by square root of sine in bracket x plus 0 and plus square root of sine x. Now here we cancel 2 from numerator denominator and 2 inside the cosine bracket. So finally we left with that equal to cos x upon root sine x plus root sine x, that gives us 2 times root sine x, and therefore f dash x is equal to cos of x upon 2 square root of sine x. So this is a required solution for the given problem. Thank you.